So once again, let's have a short overview what a chemical equation is. So what is chemical equation exactly? So a chemical equation is a shorthand technique to represent the components of a chemical reaction. As I've mentioned earlier, this is a shorthand way. There are different pieces of information that help us to determine about the different names of chemical compounds. Starting from hydrogen oxide, okay, dihydrogen oxide or water, okay, then carbon dioxide or what we call CO2. So therefore, in this information, this helps us how to work with the chemical equations and how to solve problems through balancing chemical equations by determining about the reactants. Then we also have the reaction arrow or yields to before the chemical reaction takes place and what happens after chemical reactions, and that's what we call product. In here, the number written before the compound, okay, in the first component of the reactants. As you might notice, sometimes it is combined with other groups of compounds, but in the same component of the reactants. Okay? So this number, what we call molecules. Am I right? So this number written before, that's what we call coefficient, followed by the first compound with a combination of two or more elements. And what is this number? For example, CO2. So after, numbers after, okay, written after this element, this is what we call subscript or number of atoms. Okay, I have to discuss this with you step by step. And CO2, remember, to determine what kind of state, okay, this one is gaseous state of matter. Then, it is combined again with another component, okay, with 6 molecules. Because remember, this number 6 indicate as coefficient or number of molecules. And then followed by, okay, 2 atoms of hydrogen and 1 atom of oxygen. What is the gaseous state of matter of hydrogen dioxide? Dihydrogen oxide. Liquid. Okay, that's right. So remember that H2O, okay, that simply says water. CO2 simply says carbon dioxide. So here, this one indicates with 2 atoms of hydrogen, 1 atom of oxygen. Okay? So yields to what happens next? Right after the chemical reaction takes place. So we have to look at the reaction arrow. This will be our guide to determine about the product. Okay? So I'll repeat. We have, okay, what we call the glucose. We have 6 atoms of carbon, 12 atoms of hydrogen, 6 atoms of oxygen, and then the states of matter is, okay, so for this part, okay, we have solid state of matter as a byproduct. Literally, we focus about glucose or food, usually taken from organic substances in our natural surroundings, from fruits and vegetables. So these are the possible effects now coming from the photosynthesis as well. Then, we also have oxygen, no, as byproduct, no, right after photosynthesis takes place. So those things, guys, this chemical equation describes how the chemical reaction takes place. Once the reactants and the product, okay, is part of our indicator to determine what will be the result in this kind of chemical reactions. Then, one more thing, I'll repeat. We were able to determine how much is the number of molecules, what about the number of atoms, okay, which one is a subscript, which one is coefficient, and how to determine exactly how to read step by step about the name of compounds. This is not only a single element, okay? Compounds are combinations of two or more elements according to chemical equation structure. You get me? So here we already discussed this earlier. So what are reactants and products? So the difference between the two: reactants, any ingredients or substances or materials that we start with. You guys understand? When we talk about the product, what is the effect? What is the result right after the chemical reaction takes place? That is a byproduct. Okay? So if there is a reactant, there is always be a product. So what are we going to react? What are we going to produce? And what will be a new substance form as we go through? So in this reaction between hydrogen and oxygen, okay, and then this is mainly the reactants yields to. We try to look at the reaction arrow. So with the product, okay, we got water. Where is this water molecule coming from? Okay, coming from the reactants, we combine hydrogen, okay, with 2 atoms of hydrogen and 1 atom of oxygen. So that's why we have H2O. Then always remember, this one, okay, written always with chemical symbol, either 2, 3, or 4 elements combined. That's always be a compound, right? And then always remember, guys, subscript. Any numbers in here which is parallel to the written compound, that always be number of molecule. You guys understand? Yeah? Okay, great. So this is mainly the chemical formula of water. What is the chemical formula of water? H2O. What is the chemical formula of carbon dioxide? CO2. Okay? So this is mainly how are we going to identify the chemical formula. So I repeat, a chemical formula is a shorthand way to represent the chemical symbol in each element and numbers to represent the substance. So as written there, for example, we have glucose. How glucose, okay, are formed? By forming 6 atoms of carbon, 12 atoms of hydrogen, and then 6 atoms of oxygen. So that's mainly the presence of carbon, hydrogen, and oxygen as combination of 3 important